All right, so in example 2, I actually just did it out. I wasn't going to talk through the entire thing because it's very similar to example 1. It is a growth, so I still set up the same way, except a positive exponent. I still continued the same way as I did up here. The only difference is your R value is 0.112 blah blah blah, but because it's R, in order to turn into a percentage, we have to multiply it by 100, so that's why it's 11.2%. So moving on to the next page, we'll talk about half-life. Don't stress out about half-life. We're just going to start with a certain amount, end with a certain amount. So let's say if I want to start with 10, this is decay, I want to end with 5, because that's what half-life is. You start off with an amount, and after a certain amount of time, it's cut in half. So it is 1600 years, so that's our T. So I'm going to have E to the R times 1600. So now I'm still going to divide by 10, and that's where this half is going to come from. And then I have E to the 1600 R. I'm going to do ln of 1/2 equals 1600 R, divide both sides by 1600. So I'm going to take ln of 0.5, I'm going to divide it by 1600, and I get this strange number in scientific notation, so let's think about it, times 10 to the -4th. That's my R value. We want to do the annual decay rate, so we are going to multiply that by 100. And now that is a negative, so we don't really need it to be negative. We know it's a decay rate. The fact that we say it's a decay rate means it's negative. So it's 0.043%. Seems like a strange number. Hopefully you can do the rest with just the notes that I'm going to put up.